Okay, so now Janusz Kamienski will talk about Django Signals.
Yep, thank you. Okay, hello everyone. I'm Janusz, and I will talk about the signals. So the plan for today is to see how people live without signals a little bit. Then we'll see how we can use signals in Django, why they're pure evil, and we'll see in details how they work and what we can do to make them a little bit goodish. First and foremost is how many of you are using signals in Django right now? Okay, who's using Django? Okay, so you're not using signals. And this is actually a good sign. All right, so who am I? Quickly about me. Some of you may know me from online activity as Ivelios. And on a daily basis, I'm working at Wix.com. But everything that I say today is just my opinion, not the official statement of my company. Yes. In my spare time, I run and play role-playing games or board games or some video games. And also I'm running and organizing some conferences. And from here, I can invite you to DevOps Days in Warsaw this fall. After work, I sometimes, regularly, I train acro yoga. So I'm doing some crazy stuff. And also I own a Git. Who's my dog? Okay, let's talk about the devil. The signals. I'm quite sure that some of you maybe tried to use signals, right? Who tried in the past? Because right now you're not using, I know that. Okay, so for the purpose of this presentation, I will go with a very, very simple example. It will be obviously a to-do list or to-do app. And it will be super simplified, but the things that I will show you can be applied to even more complex solutions. So there was a project once in a time, and business came with an idea that we want a functionality where we are sending some notifications or email notifications when our to-do is archived. So usually the approach for this, when we write our code, starts with something like this. I hope it's readable. It is. So the most important part is in here. So it's like for the model to do, we create some method called archive, which is an action. It will be called by a view or whatever. And it's checking the status, whether it's active. If it's active, we are archiving stuff. So we are changing the status to archive, saving. Then we are taking some model notification. We are creating a new notification, and something else may happen, whatever. But we are using a model from another Django app. That's how usually we are modularizing stuff. And also same thing happens with emails. We can create some object, some instance of email model, and then send it. So we are using directly models from some other Django apps. I will sometimes refer to them as applications, so let's not confuse it with the whole project. And so we have 3 applications in Django. And actually what's happening here is that to-do app is having dependencies in notifications and mailing apps. And it's calling directly the APIs of these applications. So, okay, it's not perfect, but it works, right? So our business has this new functionality. They are all super happy. They are dancing all around us that, yeah, new feature is here. But then they come back and they say, we also want to do some new action for this to do. We also want to do something else with notifications, which will probably at some point refer to our to-do. So we will be calling our APIs back. And we will have lots of these features because we all love adding some features to our applications, right? But one day, some of you may wake up in the morning, probably Monday, without coffee yet. And you will look at your system where you are calling something directly, and you will think that, okay, but now I'm calling from mailing to notifications, from notifications to to-dos. I'm also making some calls from notifications to mailing, and so on, and so on, and so on, and so on. And I have more and more and more modules, and this is growing like crazy. And it is actually pretty hard to maintain at some point, because we have something we call a big ball of mud. So we are calling directly APIs from one end of our project to another end, from one application to another application. And what can we do about this? Well, perhaps we can use signals. But can we? Well, let's dig into signals, how they work. So one application in our system may send some signal to the, let's call it engine or framework, and let's call it like this for now. And some other application may listen to the signal, and once it gets it, may react to it, doing something. So let's go into demo, because we all love live coding, and let's hope it will work. So we have this model, and we have archive action, right? So what I do, I will show you with model right now. So what I do, I'm just changing the status. Perhaps I should also check if status status is active. Then I do this action. Okay. Now the second thing is that I go to notifications to signals, and usually what people do is they receive a signal, not pre-save, receiver, post-save, and the sender is to do. Come on, okay. And also, so there's a signal called post-save. We have also pre-save. And what they do is they put some logic here. So they are checking if instance ID, so if this is just an update of the, because we are changing the state of the instance, but pre-save is also called when we create an instance. So we want to skip this case. And if it is being created, I want to do something like this. This is dirty hack, actually. Temp status. And I will use to do objects, to do objects get ID. Yep. Now, in post save signal, I want to check also if instance temp status is active. So I'm checking whether my instance status has changed from the value that was before saving the instance to the new value that is after. Now, it should work. Let's check if it works. It works. I have tests for that. So what happens here is a dirty hack, because in the instance I have already changed the value to archive in my model. But in pre-save, I'm pulling this from the database again, just to check what the status was before being changed. And I put it into some extra fields that I define on the fly for the instance. And the same instance object reference is available in my post-save signal receiver or handler. And so I can change if this behavior happened. And if it does happen, I can do something like create a new notification or whatever. In here will be just logging stuff. So this is how I've seen lots of people use signals. And they usually use this pre-save and post-save just to do some stuff. The most common case is when people are reacting to post-save just to do something. Does it work? Yes. Is it hacky? Also, yes. Should we do this? No. So let's go back to the presentation. So right now the situation is like this. I have to do this application. I have some signals, in this case Presafe, Postsafe, and my receivers are registering to handle these signals. So when to-do is creating some new instance or updating, the signal is being sent to these functions and being handled somehow. It works. Now, Presafe and Postsafe are the signals which are built in. They are built into the framework of Django, so they are provided to us. And the most, I would say, popular one among the developers are Presafe, Postsafe, pre-delete, post-delete, and many-to-many changed because they are operating on the models, so I can add some logic in the receivers and do some creepy stuff around this. Now, this is probably why most of you stopped using signals. One of the reasons, because it became so messy that actually there were like the signals were flying around your system and you didn't know how to handle them actually, and what happens under the hood, and actually where's the data at this point. And instead of big ball of mud, now we are drowning in our shitty code. So what can we do about this? We can use predefined signals that we will define ourselves. And the Django documentation actually has an entry on that, but in my opinion, in most of the some tutorials or books or anything, usually authors are focusing on using built-in signals instead of defining our own signals, which will be like actual notification information that something happened around our business logic, not the system itself. So not database, but our logic. And this is how we create our own signals. This is just a one-liner. We define some logic, something that happened, and we simply create this single tone of signal, and we'll reuse it all over the place. Now, how to send this signal is also easy. We just use the signal and use its method called send, which will send some extra arguments. Okay, so let's go into our demo again, and let's see how it will look like. So let's go to the next example. So first of all, I'm a little bit blind. Yeah, signals. So I'm going to define to-do archived signal, which will be model signal, just like that. And that's it. I defined that something like that happened in our application to the archived. When it happens, I go to the models, and when I have saved my object, I'm having this to the archived, which is being sent. Now, I can handle it in my notifications by creating a receiver for the to the archived signal, handle to the archived, which will receive this instance, this to do, and do some notification. It probably won't pass because the message is not correct. Yeah. Yeah. So as you can see, now it's all clear. If I want to find any place in my project where to the archived is used, just find the usages around the place. If I would like to do the same thing for the pre-save or post-save, it's a great mess. I have to look around, see if the model is actually the model that I'm looking for or anything. In this case, I am very explicit on the naming. And yeah, and I also define it for the things that happen in my system based on the business logic and the specification that my business has provided to me, and not some ORM functions and some database saving. Let's go on. That's the example. Okay, so how signals actually work? Has any of you ever looked into the dispatcher file and see how it works? None. Oh, one. Okay, great. So the dispatcher file, the module is only 300 lines of code long, so it's fairly short. The main thing there is a class called signal, and the most important thing in here is receivers field, which is an empty list which will store our references to the receivers. So when I want to add some receiver, I am using the method connect, which will receive, it will get the param receiver. And as you can see, it's just appended to the receivers list, just like that. So I'm storing all the receivers. They are saying that, okay, for this signal, the receivers are this function, that function, whatever. There are some other things like caching and so on in here, but we'll skip it for now. The most important thing is this field. Now, when I send the message, what happens? I iterate over all the receivers which are registered, and I simply call them with proper params. So it's a very simple solution, but has some issues. Now, we also have this decorator receiver, which we've been using. Actually, under the hood, it's calling just the connect method, and the only difference is that I can do this for multiple signals. Okay. Now, signals are broken. It's like, there's no argue to that. But how they are broken and what we can do about it. First of all, the dependencies are still coupled. Maybe we see that there's an isolation because now I'm using this to-do archived signal, so I'm no longer reaching out to some exact code or some API of the model. But in fact, under the hood, I'm still doing this, right? Because first of all, I'm importing the to-do archived signal from the to-dos application. And also I'm using model as an argument there. I don't have to necessarily, but I do. So I'm still, okay, I'm having a little smaller ball of mud, but I still have a ball of mud. What can I do to improve this? I can pull out the signals module outside of the applications and put it into something like a shared package with signals, and all applications will use it commonly. Okay, so this is one thing. And now notifications and mailing should not reach to those applications, so they are actually isolated. Now the second thing is that params are unclear for signals. In Zen of Python, we have this great rule that explicit is better than implicit, but what signals do is quite the opposite. So, for example, if I have some extra arguments here when I send the signal, I can put anything here, because when I receive it, you can see there are keyword arguments accepted. So the receiver is never sure what arguments they will get. If I change this, I may break some other application which may not be owned by me. Maybe some other team is working on it. And on the other hand, when I work with this receiver and some other team is working on this functionality which is sending the signal, I have to go into their code to see actually what information I will get. Which is like, I have to read someone else's code just to do that. And in the past, Django had something like providing args, but now it's removed since the version 4.0. And actually, it was only for the documentation purposes and also didn't work in any way for us. It was just an information, and I still had to look there. So what can I do about this? I can use the messages. So what is the message? The message is a simple data class which will store only the information that I want to pass in my signal. For instance, an ID of the to-do and its title. And now I can change the implementation of my signals to use it. So I will write my own version of signals, which will be message signal, and it will accept this class, this type, which is a data class, and store it as a field. So when I send the signal, I expect that it will be passed as an argument, and I validate it against the type. So I am sure that the data that I send is of this type. Why? Because when I create a receiver, which we'll see in a moment, the receiver will expect the same thing, so the same type. So let's head into the demo. Okay. Now, let's start with, as you can see, I have already moved it into the shared package. So I have this data class with message here in messages, and I have signals also separated from any application. And in here, I have to define that I will be using my message signal, and it will be accepting, it will be working with my to-do message. That's all. Now, when I send it, I want to send, instead of the instance, so instead of this yet another dependency on the model, I want to send a to-do message with ID, with a title, which I am simply mapping from my model. But now they are standardized, and they are in a simple way provided to my receiver in some other application. So when I go to the signals, I'm no longer accepting here, I don't need this sender to do. I may use it for some purposes, but not necessarily. I'm accepting message, which will be not a to-do, but a to-do message. Now, I'm getting some simple data, and I'm not using the model at all. And the message is, again, the wrong one. So yeah, I'm gonna use this stuff. Yeah, message title. Okay, okay. Now it's passing. Yeah. So as you can see, I'm now having this dependency on the to-do message, which is not in the to-do application. It's outside. It's shared across the whole project. So I can always check its definition. I can always see what fields are there, what is their type, and so on. And they are simple. So now it's clear. Now it's explicit. What I'm using, how I can use it. Even my ID can, help me with this because I have like message, and it sees everything, thanks to the type hints, of course. But I am no longer related directly to the apps application. But am I? We'll see in a minute. So yeah, this is the example. Now, I am not entirely, because as you have seen before, in order to send a signal, I actually use this list of receivers, and I'm calling them directly. And the problem is they are being called sequentially, so one after another as they were registered. And the issue here is that it's totally synchronous. So if I connect 10 receivers, I have to go through all of them. So when there's like lots of applications using my signal, it will all be called, and my code in the to-do application is waiting for them to be finished. Which means, okay, maybe I have 5 of them, that's fine, but for 10, not so. And also you have to keep in mind that these receivers probably will manipulate on some other models which may have some other business logic, which will also call some signals, right? So at some point I'm creating this like crazy tree of signals being called by signals, by signals, by signals. And remember that Django is a web framework. So usually these signals start with some view which has to respond with HTTP response in time, and it takes time. So this is most probably why you are not using signals, because they are being processed so long and they are so unclear that it's really hard to find what's processing that long. I mean, you can always debug, but you know, in production. So yeah. And at some point you are waking up one day and you see that something is working pretty slow in production, and you are digging into it and looking which post-save or pre-save or something caused it. So what can we do about this is the coupling of the services. So we have to make a paradigm shift, because Django in its construction is rather pushing everyone, especially people who learn how to use Django, into the hands of creating a huge monolith. And since we have isolated applications, as we know, almost isolated, we can transform them into services, which will be actually separated. And they should communicate with some event bus, which is separated from all of them. So when to-do is sending some signal, actually an event, a message in the event here, other applications can collect this information and process it, but this will be done asynchronously. So how can we split the monolith? This will be the most complex thing in this presentation, so stay with me. I will define my own event signal, so yet another type of signal, which on send will take all the receivers and call them in a different way. Because actually what I will do, I will take the message, I will serialize it, let's say into JSON, and then I will push it as a task. For the purposes of this example, I will use Celery. I will push it to the queue, and then what I will do, is that I will run some workers for Celery, which will do the opposite thing. So they will consume this message by pulling it, deserializing this message back into my simple data class, and use it with this receiver function. And all of that will be actually pretty transparent in usage to keep the interface that we've been using up to now. Why? Because we've been building an application which was good enough until now, because now it's slow, and we want to, split it somehow. So we want to keep the interface for now as is, and we want to do this in the background. And what's important here is that, in fact, we are doing this when sending the signal. We are doing this for all receivers. We do only this part. So it's fairly fast, right? Because we are just iterating over all receivers and simply serialize the data and send it to the queues, like specific queues for each receiver. And then we return some response. All right. Now implementation. This is the whole implementation. I just create my own new receiver, actually, and it will do, like receiver, I mean the decorator for the receiver, which will be doing exactly this stuff. First, we define private anonymous, let's call it anonymous function, which will be a decorator for deserializing the data and actually running our function, which will be decorated. Then I use this function to create a task, Celery task of it, and I register it into my Celery application. Then another thing that I do is actually I define my own producer function, which will serialize the data and push the task to the queue, and I register it as an actual receiver. Then I simply return the function. How it works? Okay, let's go on. So I have this implementation here. What I changed the naming actually from message signal to event signal, but the implementation of the signal itself is the same. Nothing changes there. I don't have to change anything about sending the message, so this is left intact. And now instead of module signals, I call it event handlers. I have this handler here, which is just a signal handler. But what I do is I use my own decorator. So this is the only change I do. And how it works, when I start the salary worker, when I start the application, and I go here, and okay, let's have an active to do. And actually, I have added also to the admin an action to archive, which is calling the archive method on the model. So it's pretty simple. When I run this, what is happening is that it's receiving the information, it's sending the signal, and the signal is then processed by the salary task. And what's worth noting here is that I'm still having the same name of the receiver function. So from the salary point of view and configuration of the salary, I'm still using the same name, same path to the to my function, so I can configure salary as usually. So in fact, I wrote, okay, let's see it here. I have it here. Yeah, I'm writing a salary task here, but it's called event receiver because it does not only register the salary task, but also registers a handler for my signal. So that's it. And what else I can do, where can I go from here, is, first of all, remove the salary and RabbitMQ, because it's just an example, but in real life, you can start with it, but then it will be nice to go into more event-driven development and use some actual solutions for that, which are technology agnostic, because salary is like solely created for Python, and use maybe Kafka, Apache Kafka for that. And that would probably mean that you have to get rid of Signal from Django and replace it with your own implementation of Signals, which will be doing this instead, and maybe just use another library. From this point, you can simply start to refactor your code and remove the receivers and remove the, sending the signals, and instead simply push the event actually and receive it on some other side by any application, which doesn't necessarily need to be a Python application even. Yeah, and one issue that someone may arise here is that I have split the applications, but at some point I may want to reach out to the, in this case, to the notification, to the application to call some procedure to do something. So I have to also implement the communication back from the receiver to the source application. And this is not covered here, obviously, but for that we can use RPCs. gRPC is getting lots of traction recently, so you can use it for that. Yeah. So your takeaways for today is do not create unnecessary dependencies when creating a new project or working with current project. Try not to call APIs from one app to another app, or let's call them now service to service. Never use built-in signals of Django unless you are extending the functionality of Django itself. So you want to extend the models, or you are creating some technical functionality which will be purely technical. Then you can use them because that's what they are for. Use custom signals, source them from the business logic that you get as with your features, with your user stories. And always favor explicit over implicit, but you should know that already. Always think how you can build applications together to scale them in the future, because right now maybe you are starting with a fresh Django simple project, so it's easy to build a monolith, but then you have to keep in mind how to split it in the future. And the best idea is to do it step by step, so maybe stay with the same interface of your functions, or in this case receivers, but in the end think how you can replace them. And read the source code, because dispatch module was only 300 lines of code, and this is how easily you can understand how signals work and think about some new solutions for that. And that's it.
Great, thank you very much. So we have a few questions. I think some of these have been answered during the talk later, but
okay, I will look
yeah.
at them. Okay, so about the crash, yeah, I'm aware that there are like issues that, when application crashes, perhaps the database has already saved the value, but the signal hasn't been dispatched. This is the issue that needs to be covered somehow. Usually we use atomic transactions for that, but it's not the perfect solution. Actually, I was discussing today with someone else about this case. It's not easy to handle. There are multiple ways you can approach to this. But in real life, I didn't have this issue yet. So it's like, you have to always think whether your data is like, okay, I'm okay with this notification not being sent because it's not that important, or maybe I'm using some, I don't know, very important functionality which is like very sensitive data and I have to process it somehow. Then you have to look deeper and find some solution to make sure that the data in the database is saved, and at some point, at the same time, the signal, the event is actually sent. But yeah, it's not covered in the presentation, obviously. But this is a good idea for the next presentation.
Thank you. Okay, next question, how to avoid signal loops?
That's a good question, actually. By building a good business logic in this case, because when you are using the signals explicitly and you have defined signals, you know that this logic should not happen in some other cases. Like, I have archived my to-do, so why it should be being archived again? And I think this one is fairly easy to being caught when you are writing good integration tests for your code. And it would be not that easy to catch if you would use still Postsafe and Presafe, because then everything may happen,
Thank you. And what about bulk actions? Is there a way to use signals with them?
Bulk actions. I believe it's about bulk actions like we have in admin or something like that, or maybe processing multiple data at the same time.
Exactly. It's about the Builtin creating directly to the database.
Yeah. So yeah. So first of all, in Django, in the implementation of signals, you have something like batch send, I believe. And this is something worth looking into, and also implementing some way of sending them as a separate sense of signals for each receivers. You can also send it as a separate receiver with the list of all instances that you want to pass. I mean, it may be some simple IDs or something. Then put it on as an event to some service which will split it actually and send it forward. So you have to think. Yeah, exactly, like this.
Okay, thank you. And the last question, why not just always use messages instead of signals?
That would be the best thing to do, actually. But the case that I'm covering is like people are, hopping on the hype train of Django. Let's make an application that's super easy with Django, and then we are building a next functionality, next functionality, next functionality, and at some point, there's this Monday when you wake up and you see this code and you are like, not anymore, and you want to split it. So obviously, if you have resources, if you have time to build the whole, infrastructure under the event-driven development and the whole domain-driven design even, if you have time and resources for that, go for it, especially if you know that your application will grow. But In some cases, especially like startups, we don't know whether it will, grow over time, or maybe in 1 year our client or our product owner, manager, whatever, the business will come and say, we are closing this. So maybe it's not worth our time and resources to do this whole implementation, because remember that introducing event messages is also costful in the matter of resources, because if you want to use Kafka, go for it, but you have to have people to manage this and do the whole administration, which is not easy actually. And if you don't have these people, maybe you should start with something simpler, but then have a plan how you can slowly move out of this monolith into some other solution. And maybe event-driven development is not something you would like to do. You have to think about this, with the context of your own project. And that's it.
Yeah, this is it. Thank you very much.
Thanks.